All right, let's talk about immunology exams. Today, we're not just going to cram facts. We're going to learn how to actually think like an immunologist. This is your guide to cracking the code on this stuff and really mastering the logic behind the immune system.
And let's be real for a second. Immunology can feel like you're facing the final boss in a video game. I mean, you're staring down this crazy alphabet soup of T cells, B cells, IL-2, TNF-alpha. It's a whole world of complex pathways, and yeah, the sheer amount of information can feel pretty overwhelming.
But here's the secret. This is not just a memory test. It's a reasoning test. It's all about understanding the beautiful, logical system behind it all. And trust me, with the right strategies, which we're about to get into, you can absolutely crush it. Think of this as your personal guide to victory.
Okay, let's gear up. Our first weapon is all about thinking in sequences. You know, the immune system is basically a master storyteller. Every single response is a perfectly planned out sequence of events. Your mission is to learn those stories, not just memorize the names of the characters.
So, you open your exam paper and you see a question like this. This is a classic. It's designed to see if you get the process, the step-by-step. They're not looking for a simple one-liner like, oh, LPS causes fever. Nope. They want the whole story, the full play-by-play of how your body makes it happen.
And here's that story laid out step by step. It all starts with recognition. A macrophage, using its special toll-like receptors, spots a bacterial component called LPS. That sets off the alarm, triggering the release of interleukin-1 or IL-1. IL-1 then travels all the way up to the hypothalamus in your brain. That's your body's thermostat. There it causes the production of something called prostaglandin E2. And that molecule is the one that actually cranks up the thermostat, giving you a fever. See, it's just a perfect, logical chain of events.
So the huge takeaway here is this. Every mechanism is a story. If you learn the plot, the cause and effect, the names of the characters will just fall into place. Once you get the story of how a fever starts, you can answer any question about it, no matter how they word it.
Now, let's grab our second weapon, mastering the art of comparison. Immunology is full of concepts that seem kind of similar at first glance, but by really digging in and comparing them, you build a much deeper, more solid understanding of everything. Let's take a classic head-to-head, humoral versus cell-mediated immunity. The biggest difference between them is where the fight happens, the battlefield, if you will. Humoral immunity is all about fighting invaders that are floating around in your body fluids, like your blood. Cell-mediated immunity, on the other hand, is the special forces team that goes inside your own cells to take out enemies that are hiding in there.
And we can break that down even further. Each side has its own star player. For humoral immunity, it's the B cells. They're the ones that churn out antibodies. For cell-mediated immunity, it's the T cells, which are basically the assassins of the immune system. And they have different targets, right? Humoral is great for neutralizing bacteria and viruses out in the open, but cell-mediated is what you need to eliminate cells that are already infected. It's a perfect division of labor.
You see, this whole comparison thing is a fantastic study tool. It forces you to define things not just by what they are, but also by what they are not. And when you do that, you create these really strong connections in your brain, making all this information so much easier to remember.
And now for our final weapon. This one is absolutely crucial for any exam, learning how to spot and dodge the examiner's traps. These are those sneaky questions designed to test just how precise your knowledge is and to catch common mistakes. But don't worry, once you know what to look for, you can sidestep them easily.
Okay, here's a perfect example of a trap question. The examiner asks you to distinguish between affinity and avidity. Now, these two words sound super similar, and they both have to do with binding strength. The trap is thinking they're basically the same thing. But in immunology, details matter, and this is one of those subtle but really important distinctions. Okay, first, let's talk about affinity. The easiest way to think about it is like a single, firm handshake. That's affinity. It's the binding strength between just one antibody binding site and one little spot on an antigen. It's a one-on-one interaction. Simple as that.
Now contrast that with avidity. If affinity is one handshake, avidity is like a whole bunch of people linking arms. It's the overall strength of all the binding sites working together. A great example is the IgM antibody, which has 10 binding sites. Avidity is the total combined force of all 10 of those connections at once.
So here's the absolute key, and this is where people get tripped up. The trap is thinking that avidity is just what you get when you add up all the individual affinities. It's not. It's way more than that. It's a synergistic effect. The whole is much, much stronger than the sum of its parts. One handshake might be easy to break, but 10 people linked together, that's an incredibly strong bond.
So there you have it, 3 really powerful tools to put in your immunology arsenal. This is all about working smarter, not just harder. Let's do a quick recap of your new winning strategy.
First, think in sequences. Remember, everything is a story. Learn the plot. Second, master the comparison. Know what things are, but also what they're not. And finally, learn to spot those examiner traps. Pay attention to those tiny but crucial details, and you'll always be one step ahead.
When you start using these strategies, you're not just studying for a test anymore. You're actually starting to understand the incredible logic of the immune system. You're really learning to think like an immunologist. So the only question left is, are you ready to crack the code?